a little bit late, but it's not worse. It's the live stream. We build something electronic and have fun doing it without any project manager's deadlines or anything that takes the fun out of it. So we simply design something. It don't even take such a big look on economics. We simply do something nice. Why not? So now we were working on this power stage layout, and the problem was the dimensioning. So that's our LED controller. We built an LED controller. I should mention that. So, and I see I should have another window open, and I will open it quite quick. Well, 1 second. Like this. This here, this. Okay, now everything looks good, I suppose, and it does. Okay. Yes, we'll continue on this part of the Power Manager, and we stopped last week because I couldn't get the right window on my PCB calculating tool for some reason. But I finished that problem off stream. Yes, of course, you need to go into another window to open it, obviously. So yes, what's the problem? We need, effectively, we do need to get thick enough traces here and here to reduce the amount of voltage drop, because we don't want to have a drop voltage at our output. That wouldn't help us. So we work on that. For that we use that PCB calculator tool. And of course, if we say we want to have a maximum of 1% voltage drop here, we can these areas are so wide we can effectively ignore them. We need to have thick enough traces. So I have my calculator here because yeah, FAO. Who uses FAO? Yes. So of course, for the big track we will have an for a big track we will have 3 amps of current, and with only 1.5% of voltage drop, it would be 0.06. So with 12 volts. So we want to have an voltage drop of 0. Want to have so 4 ohms. Yeah, thank you very much. 12 ohms, and we only want to have a voltage drop of 3 amps. No, of 1.5%. We are only allowed to have 0.02 ohms at our trace. So we can take a look and see how long it is, so we can calculate it. That are around 20 millimeters, and 20 millimeters result to 7. This is really bad. I change the units. If I change the units, I get the right amount directly. Let's do this. It's not Steuerung U again. That's unfortunate. Edit. Let's give me some units. Shift U. So our trace is 770 volts long. and we are only allowed to have 0.02 ohms. So we go to the not conductor properties. Here. We have in DC. We have one. We have basic. We have a basic 1 ounce of copper PCB. We don't dare to buy something more expensive. Why should we? A bare PCB, and we have a conductor length of 780 thou or mils. PCB thickness is not that important, and a conductor width of how big does it need to be? 10 mils is not enough because we are over 0.02 ohms. 100 mils is more than enough. And 100 mils, I think that are 3 millimeter. I open up a calculator, so yeah. Okay, you could use an inch of trace, okay. What about 50 millimeters? Yeah, that would be okay. So we could use a 2 millimeter trace, and when everything's good, yeah, we'll simply use a 2 millimeter trace. 1 millimeter would be sufficient too, but thicker is in this case actually better. So let's go for 100 mil trace. Oh no, that doesn't look good. Let's do 100. Let's do 75. That's also in the range of will work. We'll put that in a nice perspective. And then try to, we want to, actually we don't want to do this because if we put it in like this, it will make our soldering, although it's not that much of ground plane. Yeah, we can do this. We'll immerse the contacts, which are high power, directly into the trace. So these two conductors. We will update our okay, now they're not immersed enough. Let's immerse them further. Let's remove that point. We don't need this. No. Can I remove that point? Not that easy, so we want. Let's immerse everything in that. Let's immerse everything that needs to be immersed in that pore. And here we'll get some thermal insulation. That's good. Okay. And now it looks good. These aren't high current wires at all, so these can be normal, and this can be normal too. And aren't high power wires at all. So, and with this added, can almost start. Next we will need to add some positive voltage plane. It needs to be the plane because we need to get heat out of the device. And for that we will simply start adding a big plane right here. what we will try to reduce is too much coupling into the capacitors. Okay. Now we need to know which trace is a VCC, because I suppose it doesn't have a name yet. So we'll check that net. Yeah, it's net 0. It's VCC. Okay. And with that we can get some VCC here. Oh yeah, we need to update the schematic first. Need to save it. First of all, important that we save that one. No, we didn't. So, no, it's okay. Now we can renew the schematic by reference design. Okay. Okay. Now this net should be named VCC, and it should be yes. Now it's in the net list. That's good. Let's start here again. So let's give it a little bit of distance here. And add a plane here. Connected directly to VCC, because thermals 4-spoke. Okay. Okay. Okay, at which point? Is it this clearance here? That's a problem, I think. But no design rule check error yet, so that's okay. But this one should be connected directly. This one here too. So we'll separate this one here in two. So we'll make this one a bit smaller, because these two pins need to be immersed directly into the plane. If I remember that correctly, let's take a look on the reference design. Because for reference design, they sure made it right. Besides having a possibility for besides having a problem with EMC maybe. But yes, although we'll immerse those directly, you can immerse all of them directly. Although no, let's look like this, and add another copper port. So you want to have a direct connection, okay? After we have connected it to ground. Connectivity, connect to net VCC. Yes. Okay. Make this one a little bit more straight. Pour this in. Okay, that's good. I like it. And the same here. We'll add a more direct connection to this a more direct thermal connection to this one. That's ground, so let's connect this directly to ground. And there's our ground. Or is it here still net 5? Ah, that wasn't right. But no, it's net 2. Okay, good. Then connect it directly to net 2. Okay. Okay. Here it's net 5. Oh, it's everything net 2. Okay, why do we have two ground planes? I don't understand that. No, that's okay. So that net 5. I will check the design. We'll check the clearances on the on this later. So put that on 1. Okay, I like this. That looks good. So that should be everything that fits into one. So okay, these need to be placed yet. Also, we'll try to make them a little bit more hidden here. So we get some space for our circuitry down here, because we still need to add 2 more of these on the PCB and on that area of the PCB. Yeah. And by class, that's not right. We changed the default net class, what? Let's go back to millimeters again and check the net classes again, because that's not right. We should change that. More of the net classes. Your net classes. Default should be 0.3 millimeters. Yeah, that looks more correct. Let's keep it around that to reduce coupling. In here, and move that to the side. Oh, here we don't need to change the layer. Here we can simply stay on the top layer. Okay, yeah, that should be enough for the first one. Now we need to do this 3 more times, which is of course pretty great. But I will try to do the following. I will try to place the components on the right height, and then simply move it by an offset to get the placement right about 90%. And then a change on the smaller things. One thing we can do directly is getting these holes right. Because these holes are currently only part of the imported cut or imported DXF, but they need to be part of the they need to be part of the design, so we don't get less errors. Yeah, so how can we place them so they are really let's start with 0, keep out, place them correctly inside here. That's, I think I made them 0.5. Yeah. Place them here. Then you can remove them. And give it the right amount of keyboard, 5mm. And lock it. So it won't move anymore. Although I think we still need to move all. We still would need to move all of that to up here and arrange it with the holes. So let's don't do it yet. That could be a problem if we do it now. When we start to remove and move everything, and now let's do it later. That's easier. So let's continue. L2, L3. Now we'll do all the components in bulk. Start with L2. And L3. So I suppose we're on the right height. We'll simply start from directly here. So that's 10,977 minus 29. And that are... So let's increase it by 30mm. 197. So. And same with that one. And I'll put this on 70.97. Okay, but it fits great. Even with a 5mm keep out on the holes, that would be important. But if that fits, that's of course great. Because we, yeah, that's great. That fits perfectly. So let's continue with the IC. These two here, U7, U8. And we'll add those. I think U7 will be channel 2. Yeah, like this. Bring it on the right height. Get the X coordinate here, 2177. And it will be 51777. 51. 7. So. Yeah. Let's keep it correct, 772, and that means it will 81772. So like this. 8177. No. Great. So let's continue with C32, C30 C30 equivalent. So I'm currently thinking, can I copy that 1-to-1 over? Because that would make things so much easier. Or like, take a look on this later. Or I imagine, is there an possibility to do this automatically? Dip trace. Let's Google that. PCB. Oh, there's a tool for that. Let's check this. So let's copy that. Edit. Copy matrix. Rows 3 and of course, the problem is now, if we do that, we can duplicate it completely. That's of course great, but we're not able to keep the design. Let's see. Okay, there's a thing that's called hierarchical sheets. Like, you can do that in schematic. Okay, let's try this out. I have no idea how this works. I think we need to... No, we don't want a new sheet. Okay, let's check that. Dip trace hierarchy. Let's check it out in the one big dip trace document. because that's something I've never done before. Let's check that out. Hierarchical schematic, okay. We will design a very simple 2-level here. Sheets are select the second sheet. Okay. Okay. Let's try to understand that on stream. Why not? Okay. Okay, so sheet type, to make it hierarchical. Okay, so now some of the parts should have been converted to something hierarchical, I suppose. So until now it doesn't seem so much of a change. But we should have been converted, don't they? Because at this point these should have gotten square, because the square ones means that they are hierarchical. Okay. Yeah, they should look like this. Okay. So that would mean we need to replace all of them. Nope, that's something I will read by myself to get it working. No interest of doing it in stream now, if I'm honest. Good, then only half an hour for today, because there's a possibility to save lots of time. We want to do this on stream. We will do this on we will do this while I already made that, and we'll implement changes or see the changes in the next one. Goodbye.